Hi friends, welcome to my channel. Let's have a look at the new problem 2352, equal row and column pairs. So in this video, we're going to share a solution based on simple counting and summation. So this problem asks us to return the number of pairs Ri and Cg such that row Ri and column Cg are equal. So let's look at the two examples here. So in example 1, the return is 1. So row 2 and column 1 are the same. So both are 277. And in example 2, the output or the return is 3. So here are the explanations and the three pairs. So the constraints on this problem is mainly about the size of the grid, so which is bounded above by 200. And the third constraint is not that essential for us here. So our method is based on simple counting and summation or check. The idea is simple. So we regard each row as a tuple and count the row and row frequencies. We are going to do the same for the columns. In other words, we do it for the transpose of grid. So if a row appears k times in grid, and the same row appears m times in the transpose, then this row contributes to the final sum by k times m. So what we want to do is actually summation these km pairs. So let's look at one example we cook up to show or fix the idea. So if the grid is given by 221, 221, and 111. So in the grid, so 221 appears twice, and 111 appears once. If we look at the transpose, we see 2, 2, 1, 2, 2, 1. It also appears twice, and 111 appears once. So the return is 2 times 2 plus 1 times 1. So that's 5. So that's actually the explanation for this example. So now let's look at the short code. First, we are going to do the counting. So this can be done using a dictionary. So as dictionary key should be immutable, so we actually convert the list to a tuple. So let's see row counter. So collections, let's use a counter for convenience. So we're going to tupleize, so the item or the row for row in grid. So that's one counter. Let's do the column counter. Then it's collections counter. So we're going to do atom for atom in zip, so star grid. That's it. So here we do not need to do type conversion because atom itself will be tuple in this return of zip function. So with that said, we're ready to do the counting or do summation. So we just need to check once the case in the row counter. So let me first initialize a result so that we can return its final state. So for k in row counter, then we're going to increment the result by the corresponding sum. So that is row counter k times the frequency in the column counter. That is column counter. So I'm going to use the get function. So if the k does not exist in the column counter, we're going to set the frequency to be 0. So this increment is nothing but 0. So with that said, I guess we are ready to return the result. So that's it for this problem. Let's do a special case check. Yeah, it passes a special case. Now let's look at the generic case. Yeah, it passes all the generic cases. So that's it for this problem. Actually, similar idea can be used to solve the for some problem. So it's good to have a try. So thank you so much.